All right, this is your recording for your activity 14 through 16 review. Just going to go through again, not every problem, but just at least covering one thing of each type. We'll start with number one. So they gave you a function in number one where you had v of w, which was equal to 120 minus 6w times w squared. So first thing it asks you to do is to find the reasonable domain. Now remember that the background on this situation is this is representing the volume of a box, of a rectangular prism. So this is like what we did in 14.1 where we had made a t-chart of different values for the width and then use those to find the volume. So you can certainly do that here if you want to pick values for the width. The first part of the domain should be kind of common sense because you know that the lower limit has to be 0 because you can't have a box that doesn't have a width. If the width is 0, then it doesn't make a box at all. So you know that the lower limit has to be 0. The key is that you need to figure out what the upper limit is. And there's lots of different ways that you can do that. One way is to simply make a t-chart and keep picking bigger W's until you get something that doesn't make sense. Because you can't have a W value that would force your length or your height, however you're thinking about it, to be 0, because again, then it wouldn't make a box. Certainly you can't have a width that would give you a negative value for volume because that doesn't make sense either. So there's lots of ways that you can do it. You could make a t-chart and kind of guess and check. What I did is I found the x-intercepts and I did that algebraically because it was already factored. If it's already in factored form, all you have to do is set each of these equal to 0 to find the x-intercepts, because remember from Unit 2 that we find x-intercepts by setting y, which in this case is v of w, equal to 0. So if I put 0 in here, that means either 120 minus 6w equals 0 or w squared equals 0. This one's easy to solve because we just take the square root of both sides, and the square root of 0 is 0. We don't need to put the plus or minus here because positive and negative 0 are both 0. Over here, to solve for w, we would add 6w to both sides first. So that gives me 120 equals 6w. And then we would divide by 6. And so we find that w equals 20. Now, since there's only two x-intercepts, that's all we need to consider. So we know that if I had width of exactly 20, that would make my height 0, which doesn't make any sense. So that is why I have the domain in part A as the lower limit being 0 and the upper limit being 20. Please be careful and make sure that you use the right variable. This is a w, not an x, and it's important, even though a lot of times we use x to represent domain, that you use the correct variable. So that's inequality notation. Remember interval notation. We got the lower limit and the upper limit. We use parentheses because there are no equals. These are not included. If they were included, we would use a bracket. And then finally, set notation. Remember, it always starts out the same way. Whatever your variable is, so in this case w, then you draw the line that means such that w, this symbol, which means is an element of the real numbers, and then we just rewrite our inequality form so that w is between 0 and 20. So inequality notation, interval notation, set notation. B asks you to graph it. And I'm not going to draw the whole graph because on the answer sheet I give you an exact picture of what the graph is supposed to look like. But I am going to point out a couple things. Do not forget on part B or anything that tells you to graph to label the axes and give a scale. Tell what you're counting by. Tell what the units are. So don't just write width, write width in parentheses inches, because that tells you what you're measuring in. The other thing to remember on part B is that this is not going to be a rough sketch. You need to have some actual points. So remember that you can get actual points by pressing second graph once you've typed the equation into your graphing calculator and chosen an appropriate window. Now, a lot of you are still having trouble finding an appropriate window. If your domain has to go from 0 to 20, let's say we pick 10 because it's halfway between. If W is 10, 120 minus 6 times 10, which is 60, times 10 squared, well, this is 60. 60 times 100 is 6,000. So you need to make sure your y goes up high enough. So if this gives me 6,000, it might go higher than that because we go all the way to 20. So I went up to about 8,000 on my original graph when I did it on my paper. Again, you can press second graph once you have the right window in order to see the table so you can get some actual points to plot. Be careful about how you connect them. The general shape on this guy, some of you are making your shape look like a parabola. Some of you are drawing me something that looks like this. This is wrong. This is a cubic graph. We're restricting the domain, so we're not looking at all of it, but it looks like this. And this one keeps going down. If you were to not restrict the domain and look at the whole graph, there's a valley over here. So there needs to be this tail and this increasing. It's not just a parabola. So please be very careful, making sure you're attending to precision and just not being sloppy with your graphs. That's going to be important. Part C asked you to find the maximum. So again, you can see the answer. I'm not going to write it down again. It's on your answer sheet, but you find it by doing second trace and then choosing where it says maximum. And then you do the left bound, right bound to find the coordinates of the point. D then asks you to interpret that by saying what is the width that produces the maximum volume. So since your ordered pairs are width comma volume, the width that produces the maximum volume is the x coordinate of what you found in C. All right, so that kind of helps you out with graphing. Number 3 is graphing. Number 4 is also graphing. Again, on those ones, I just want to tell you, again, don't eyeball it. I know that number 3 is a small graph, but you can't, on the relative minimum, just look at the graph and say, oh, it looks like it's at 1, -1, because it's not. It's fractional. So you have to, when you're asked to find a maximum, a minimum, an intercept, you need to make sure that you know for sure where it is. And again, you can do all that in the second trace menu. Second trace min, second trace max. Remember that x-intercepts you find by doing second trace 0, which is choice 2. So don't get sloppy. Actually make sure you know the exact answer. Number 8, I'm going to do simply because that was the one I made a typo on. So just in case I forgot to announce the typo in class. The problem originally had asked you to do several things, the first of which was to decide if it was a function. So originally, 8 said f of x equals x to the 4th plus x plus 5 minus 1/4 x cubed. So remember, to decide if it's a polynomial, polynomials, 2 things have to be true. 1, all the exponents have to be whole numbers. So I look at my exponents. This one's a 4. This one doesn't have 1, but it's understood to be a 1. This one would be x to the 0. This one is a 3. So yes, my exponents are all whole numbers. The second thing that has to be true is all the coefficients, the numbers in front of your variables, have to be real numbers. Some of you, even though we talked about this in class, still don't know what a real number is. Real numbers are anything that you could plot on a number line. Doesn't matter if it's a decimal, a fraction, a square root, anything that you can plot on the number line is a real number. The only things that aren't real numbers are imaginaries. So my coefficient here is 1, 1, 5, negative 1/4. None of those are imaginary numbers, which means they're all real. So yes, this is a polynomial. So it said, if yes, write it in standard form. So that means highest exponent to lowest exponent. So highest exponent was x to the 4th, followed by my x cubed, minus 1/4 x cubed. There is no x squared, so next goes x to the 1st, which is plain x, and then my plus 5. This is standard form. This is where the typo was. I told you to correct it in class, hopefully. But if I forgot, I just accidentally typed a 3 instead of a 4 there. I'm not exactly sure why, maybe because the exponent was a 3. But either way, this is the answer. Then it asks you to state the degree. Remember, the degree is the highest exponent that you see, so that would be 4. And then it asks you to state the leading coefficient. So the leading coefficient, remember, is the coefficient that comes first when it's in standard form. So here's standard form. The first coefficient is an understood 1. So the leading coefficient is 1 there. All right. Next thing I want to talk about is end behavior. Number 11 kind of addresses end behavior, and so does number 13. Remember, end behavior is your dance moves. So if the leading coefficient and the degree are going to tell you what it should look like. So if the leading coefficient is positive and your degree is even, your dance moves have both arms up to the sky, because both ends of the function are approaching positive infinity. If the leading coefficient is negative and the degree is even, then it gets flipped upside down. So both ends approach negative infinity. If the leading coefficient is positive and the degree is odd, then your sweet dance move looks like this, meaning on the left side of the graph it's going down and on the right side of the graph it's going up. If the leading coefficient is negative and the degree is odd, then it looks like this. Left side of the graph goes up, right side of the graph goes down. So you have to know this. This has to be memorized. You also have to know what arrow notation looks like. Some of you, as you're asking me questions, didn't know what it meant still. When I list arrow notation, remember that pretty much it always starts out the same way, as x approaches negative infinity. And we said in class, and I even wrote it above, that this means as we look on the left side of the graph or on the left side of the graph. So on the left side of the graph, we are just describing what is happening to f of x. So in number 13, the function was negative x cubed plus 7x squared minus 11. So the leading coefficient was negative and the degree was odd. So that means this is your dance move that you should know, which means, again, you have to know and to be able to write this, but this means on the left side of the graph, f of x, what does it do? Well, here's the left side of the graph. It approaches positive infinity. It's going up. Then the other part, as x approaches infinity, which means on the right side of the graph, so here's the right side of the graph, the arrow's going down, which means that f of x then is approaching negative infinity. So it approaches positive infinity if the arrow is going up. It approaches negative infinity if the arrow is going down. Next thing we talked about was whether functions are themselves even or odd. So in your notes, we did this both graphically and algebraically. So graphically, it's even if it's symmetric about the y-axis. It's odd if it's symmetric about the origin, which again, I described symmetric about the origin several ways. We said that's the same as a 180-degree rotation. We also said if you take the right side of the graph, reflect it over the x-axis, and then reflect it over the y, that it should line up on the left side of the graph. That's what symmetric about the origin means. Algebraically, we said that you have to plug in negative x where x was in the original function. If what you get is the same as the original, it gives you the same thing as f of x, then it's even. If you plug in negative x for x and you get negative 1 times the original, then it's odd. Remember that if it doesn't fit into one of these categories, then it's neither even nor odd. So I'm just going to pick one. You had 3 within the review to look at. But I'm going to do number 17. The original was f of x equals negative x cubed plus 2x plus 5. Now, if I want to know if this is even or odd, I can do it either way because it didn't specify. On the quiz, you're going to have at least one of each, so you have to know both methods. So if I'm looking at the graph, I could graph it on my graphing calculator and draw myself a sketch and then ask myself, is this symmetric about the y-axis? Well, if I flip this over the y, no, that doesn't match up. So it's not even, I know that for sure. Some people have trouble with symmetric about the origin. So again, if you turned your paper 180 degrees, would it still look the exact same as this one? Well, if I turned this 180 degrees upside down, the arrows are still going to be going the same direction. However, it's going to be below the axis instead of above, and so that's not going to work. So it's not symmetric about the origin. Again, another way that you could do that is to flip over the y-axis. So if I flip this, it looks like that. And then to flip that over the I flipped over the x-axis first, sorry. Then flip that over the y-axis, which would give me something like this. So again, this green did not match up on top of my blue. So it's not symmetric about the origin, which means graphically I have shown that it is neither. So you will have to explain or show work. So if you're doing the graph, you don't have to draw the graphs. You could explain in a sentence by saying neither, it is not symmetric about the y-axis or the origin. So that's how you would do it graphically. Now let's say you were asked to do it algebraically. Again, you have to do one or the other, not both on the same problem. But here, if I want to do this algebraically, if I do f of negative x, again, all that means is plug in negative x where x is, everywhere. So the opposite of negative x to the third power plus 2 times negative x plus 5. If I simplify this, exponents first, this gives me negative x cubed. Then I've got the negative 1 in front, so negative negative gives me a positive, so that gives me x cubed. 2 times negative x is negative 2x, and then I've got my plus 5. So algebraically, if I look at it, x cubed minus 2x plus 5 is not the same as my original. So it's not even because it didn't equal f of x. If I were to take negative 1 times my original, I would get x cubed minus 2x minus 5. So this isn't negative 1 times the original either. The signs on the 5s aren't right. So again, this algebraically shows that the answer is neither. It is not even, and it is also not odd. All right, so that wraps up the 14 review. Now, if we look at 15. Again, going back to the box thing, you can tell that this is very important, and it's one of the major things on the embedded assessment. So in number 5, it gave you a v of x. So v of x equals x times 10 minus 2x times 12 minus 2x. And it asked you to write that in standard form. So lots of ways you could do this. I distributed my x to the first term first and made that 10x minus 2x squared. And then, because these were both binomials, I FOILed. So firsts gives me 120x, outsides gives me negative 20x squared, insides negative 24x squared, and then lasts gives me positive 4x cubed. So in standard form, 4x cubed minus 44x squared plus 120x. So there's my standard form. Now, it asks you to come up with the same thing, only changing the dimensions. Draw a picture, guys, because this is very, very similar to what's on the embedded assessment. It tells you in number 6 that you are starting with a piece of cardboard or paper or whatever it is that's 8 by 14. So draw yourself a rectangle and label it 8 by 14. It says you're cutting out squares out of the corners, and we don't know how big that is, which means if it's square that both the sides have to be x. And of course, they're all the same. This visual is really important. You should always draw a picture if possible, because this is how we get the volume function. If I fold this up, remember that these parts aren't really there. So you're folding up this part, and this then becomes the height. So the height is x, so volume, height times the length. Well, the length, it was 14, but we took out an x on each end. So it's 14 take away 2x. And then finally the width, because volume is height times length times width. So the width was 8, but again, we took away an x on both sides. So it's 8 minus 2x. So that's how I got my factored form answer for 6. Obviously, the standard form, you do the exact same thing that I did over here in number 5. So this was number 5. This is part of number 6. All right, next we have some addition and subtraction problems. So not going to do both of them. I will do number 11, which is subtraction, because more people have trouble with subtraction than with addition, usually. So your original problem looked like this. Please pay attention to what you're doing. This is subtraction. Don't try to FOIL or multiply or whatever. This is subtraction, which means first thing you should do is distribute the negative. So either change the signs and circle them, or write the opposite sign just below it, and then scratch out what you had above. So I've got 6x squared minus 13x plus 4. Again, you can choose to do this vertically or horizontally. So if you want to line like terms up underneath each other and add, that's fine. If you want to identify the like terms like so and then add, that's fine as well. So regardless of which method you choose here, you should get negative 2x squared, you should get negative 6x, and then you should get negative 21. So that's your answer there. 14 and 16 and 17 are multiplication problems. So number 16, you can FOIL it because it's a binomial times a binomial. So if you didn't get that answer right, go back. Make sure that you FOILed or did a box. On 17, you have x plus 2 times 3x cubed minus 8x squared plus 2x minus 7. So this is one where you either need, and again this is a choice, you either need to do x times 3x cubed minus 8x squared plus 2x minus 7, and then positive 2 times 3x cubed minus 8x squared plus 2x minus 7. So multiplying, distributing both, or you need to set up the box. They should get you the same answer, so I don't care which way you do it. Here it would be x and 2. This would be 3x cubed, negative 8x squared. Oops, I forgot a column. Good thing I can just add it on the end. And then negative 7. So again, if you're going over here, you're just going to distribute everywhere. So you're going to end up with 8 terms, just like you're going to end up with 8 terms here. So x times 3x cubed is 3x to the 4th. X times negative 8x squared is negative 8x cubed. X times 2x is 2x squared. X times negative 7 is negative 7x. 2 times 3x cubed is 6x cubed. 2 times negative 8x squared is negative 16x squared. 2 times 2x is 4x. 2 times negative 7 is negative 14. So now I just need to combine my like terms. I've got x cubes here, x squareds here, and plain x's here that all need combined. So the 3x to the 4th just gets brought down. It didn't have a like term. These guys give me a total of negative 2x cubed. These guys give me negative 14x squared. This gives me negative 3x, and then my negative 14 didn't have a like term, so we bring it down, and there is the answer that was on your answer sheet. Next, polynomial long division. I'm going to look at 21 because it was the longer one. So you were taking x squared plus 3x plus 1 on the outside. And on the inside, you had 5x to the 4th plus 14x cubed plus 0x squared. If you missed it and you didn't do this, that's why. Plus 9x, and then I put a plus 0 on the end. Sometimes you end up needing this, sometimes you don't, but I always put it on the dividend anyway. So once you have it set up, including the zeros for placeholders, the next thing you do is ask yourself, what do I multiply x squared by to get 5x to the 4th? So the answer to that question is 5x squared. Remember that when you answer that question, you put it above its like term. Since x squared times 5x squared is what gives you 5x to the 4th, it goes above the squared term. Once you do that, the next step is to multiply. So multiply what's up here times what's in front. So 5x squared times x squared is 5x to the 4th. 5x squared times 3x is 15x cubed. 5x squared times 1 is 5x squared. Next, change the signs, all of them. And then add the columns. These cancel. This gives you negative x cubed. This gives you negative 5x squared. And then you bring down the next term. Now, just repeat that exact same process again. So now I'm asking myself, what do I multiply x squared by to get negative x cubed? So the answer to that would be negative x. So negative x times x squared is negative x cubed. Negative x times 3x is negative 3x squared. Negative x times 1 is negative x. Now change the signs. Plus, 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 and add the columns. These cancel. This gives you negative 2x squared. This gives you plus 10x. And I bring down my next term. Repeat again. What do I multiply x squared by to get negative 2x squared? I multiply by negative 2. So I put it over its like term, and now I multiply. Negative 2 times x squared is negative 2x squared. Negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. Then change the signs. Plus, plus, plus. These cancel. This gives me 16x. This gives me 2. Remember that this is my remainder because I've run out of space here and there's nothing I can multiply x squared by to get 16x. So because my remainder term is positive, I write a plus, and then the fraction always goes remainder on top, so 16x plus 2, and divisor on the bottom, so x squared plus 3x plus 1. And there is your answer for that. Number 22 is, or not 22. Number 23 and 24 are both synthetic division. I'm going to do 23. I'm going to actually kind of squish it up in this space because I'm kind of running out of space and I know I'm going to need some. So remember, on number 23 in the original problem, your divisor was x plus 4. So you change the sign of whatever the constant was in the divisor, and that's what goes in your box. So -4 goes in my box because it was a plus 4 in the actual problem itself. Then, and I should probably switch colors here so it doesn't run into this guy, but the dividend in 23 was x squared plus 4. So if I'm looking at x squared plus 4, remember the coefficients go here. So the highest exponent is 2, so that's a 1x squared. After x squareds, come x's, and there isn't an x. You need the 0 as a placeholder, just like you did over here. Then the constant term, which is 4. I always put that vertical dashed line to indicate that's going to be my remainder column. Once you've set up the box and the coefficients, then you bring down the first term. Now do box times bottom, which gives you -4, and then add the column, which also gives you -4. Then box times bottom is positive 16, and then add the column, which gives you 20. Remember, my original dividend was an x squared, which means my answer should be 1 power below that, so x to the first. So 1x to the first, which is just x, minus 4. This is my remainder. It's positive, so I do a plus 20 over. My divisor was x plus 4, so that's what I write on the bottom of my remainder. All right, almost there. The only thing left is Pascal's triangle. So remember, you're going to have to set up Pascal's triangle here. So I'm just going to draw a line. The edges are always 1s. Anytime you have something in the middle, you add the 2 numbers in the slots above it. So 1 plus 1 is 2. Edge is 1. 1. These 2 added is 3. 3, 1. And continue the pattern. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. So on and so forth. I think I have to go another. So 1, 7, 21, 35, 35, 21, 7, 1. Again, you could go on forever. Number 8 is the only one where it actually asks you to do the whole problem using Pascal's triangle. So it's a plus b raised to the 8th power. Remember, whatever your exponent is, you do plus 1 to get the row. So 9th row of Pascal's triangle is what we need. So I actually need one more than this because this is the 8th row. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 8, 28, kind of squishing it in here. Then this is 56, 70, and then remember it repeats on the way back down, 56, 28, 8, 1. Now, you lucked out on this one because they're both letters, and that actually makes it easier because you don't have to worry about the coefficients when you raise them to exponents. So there's no way I can probably fit this all on one line, but remember, coefficient first, so 1 is my first coefficient. When I start off, my a term, which is actually a, starts out high, so it starts out at 8. My b term starts out low, and this time b is actually b, starts out at 0. So that's my first term. My second term, the coefficient is 8. Now my a's should decrease, so a to the 7th, and my b's should increase, b to the 1st. Next, 28, so plus 28. A should decrease, so 6, and b should increase to 2. Next coefficient is 56. A decreases to 5. B increases to 3. Now 70 plus 70. A decreases to 4. B increases to 4. Now again, I'm going to have to go underneath because I just don't have enough room here to write out the rest. So now 56 again. So 56. A now goes down to 3. B goes up to 5. 28. A goes down to 2. B goes up to 6. Now 8. Almost there. A goes down to 1. B goes up to 7. And then the last one, 1, A goes down to 0, B goes up to 8. Remember, I had said in class when I taught this that you know you're done when you get to the last term of the triangle row and your A term's exponent should be 0, your B term's exponent should match the exponent in the problem. If that doesn't happen, then you messed something up. Either you used the wrong row of the triangle or you skipped an exponent somewhere, but you need to go back and check it. Now, like I said, this one's pretty easy to simplify because there aren't any parentheses. You don't have 2a that you had to raise, to the 5th power or whatever. So the only thing I need to do here is get rid of unnecessary 1s and then anything raised to the 0 power. So 1 times a to the 8th times 1, which is what b to the 0 is just a to the 8th. Over here, I just need to get rid of the exponent of 1 because it's unnecessary, so just write it as b. Over there, I don't really need to change anything. A to the 6th, b to the 2nd. Same thing here, 56, a to the 5th, b to the 3rd. This one's good, 70, a 4, b 4. 56, a cubed, b 5. 28, a squared, b to the 6th. Again, I'm running out of room, so I'm going underneath because this one does have something I need to fix. No written 1s there, so it's a, b to the 7th. Then over here, anything raised to the 0 power is 1, so 1 times b to the 8th is b to the 8th. So there's how we work out our entire Pascal's triangle. Again, number 9, they just did part of it for you and just wanted you to notice the pattern to finish it out. So to continue the exponents going down and up respectively. All right, so that covers all of the various topics from the first 3 activities of Unit 3. Again, please study by doing problems. Just because it made sense when I explained it doesn't mean that you can do it yourself. So please study, and good luck.